Hi friends, hi friends, good morning to everyone. Welcome to learn CSE 101 Problem Solving and Programming in C course. In this course, we are going to learn the fundamentals in problem solving and we need to cover the complete features in C language. We have the syllabus of 4 units. The syllabus consists of 4 units in which the first unit starts with the fundamentals in algorithms. Following the term, right, algorithm, and after learning the fundamentals in algorithms, and we need to enter into the language C language. Starting from the C language, constants, variables, we need to go through operators, arrays, control structures, functions, pointers, unions, files, memory allocation. These are the topics that we are going to explore in the course. Problem solving and programming in C. As the course title indicates, problem solving and programming in C. Given the real world problem, we need to think of how to find its solution. So to find the solution to the given real world problem, first we need to construct the stepwise procedure. Once we construct the stepwise procedure, then the procedure can be converted into the equivalent high level language. That means a program. Algorithm can be converted or translated into the equivalent program. We need different high level programming languages. C, this is one of the high level programming language. Using C, we can solve the real world problems. So we need to start with the fundamentals in algorithms. Now we are going to explore the topics in unit number 1. In unit number 1, first we need to focus on the term algorithm. First see, given the problem, we need to find the stepwise procedure. Stepwise procedure to solve the problem. This is said to be algorithm. So algorithm is defined as an unambiguous procedure algorithm is defined as an unambiguous procedure. That means this should be a clear procedure. There should not be any ambiguity. No ambiguity. The unambiguous procedure, which consists of unambiguous procedure, which consists of a finite set of well-defined instructions. Finite set of well-defined instructions, each of which requires a finite amount of storage. Finite amount of storage and takes a finite amount of time finite amount of time to complete the execution. This is the term algorithm. Whenever we have the problem P, assuming that P is the real world problem, we need to get the solution to the problem P. Solution to the problem. How do we find the solution to the problem P? P is a real world problem that may be operating on any of the inputs. So to find out the solution to the problem P, we need a stepwise procedure. The stepwise procedure which should tell what are the intermediate steps required. For example, step 1, start. Step 2, we need to define the operation. Step 3, define the operation, etc. Step N, we need to define the operation, or we can say print the results. Step N plus 1, stop. So this way, logically, we need to define what is going to be executed in each and every step. That is the logic of algorithm. Clearly, algorithm is defined as an unambiguous procedure. That means it should be a clear procedure. We need to clearly define the instructions in each step. So the procedure consists of finite set of well-defined instructions. Each of the instructions should be clearly defined, well-defined one. When the instructions are executed by the system, ultimately the instructions are going to be stored in the system in terms of a high-level language, say program instructions. So the program instructions space, memory, how much memory is required to hold the program instructions. We have the finite amount of storage. Storage should be finite amount, for example 5 KB, 10 KB. And to execute all of these instructions, step 1, step 2, step 3, etc. Here, all of these well-defined instructions. We need the finite amount of storage and finite amount of time to complete the execution. So we have some stepwise procedure. The procedure is converted into the program. When we run the program should take finite amount of memory, and within the finite amount of computational time, say 5 milliseconds, 8 milliseconds, or after 5 days, or after 25 days, the program should come to the stopping state, ending state. So this kind of a procedure are going to be executed by a mathematical machine. Procedure, unambiguous procedure is executed by a mathematical machine such as a digital computer. So understand the term algorithm. Algorithm is an unambiguous or a clear procedure which consists of a finite number of instructions. The finite number of instructions are defined in terms of steps. When the steps are executed by the high level language, or when the steps are executed right by the machine, mathematical machine, digital computer, the storage should be a finite one, and it takes the finite amount of time, time complexity, right? Or computing time, that should be a finite one. If it's so, then it is to be an unambiguous procedure. So to solve the given real world problem P, we need to first construct algorithm. So algorithm can be represented in different ways. How do we represent an algorithm? Just see, how do we represent an algorithm? Algorithm can be represented in terms of pseudocode. It can be represented as a diagrammatic representation, flowchart. These are the ways of representing the algorithm. Now we are going to write, or we are going to design or write algorithms for the simple problems. Before that, you need to understand the criteria of an algorithm. Based on the criteria, we need to write the well-defined instructions. Criteria of an algorithm. Every algorithm is concerned, it should satisfy some criteria. The criteria are: first one, input. Input is concerned, right? This is the most important criteria in every algorithm. Without giving input, for example, this is the algorithm. We are going to provide the input to this algorithm. The algorithm produces the equivalent output. That's what algorithm is said to be: the input output transformation. Input is transformed into the required output. Who is the role algorithm is performing? The input output transformation. As far as input is concerned, how many inputs are required? How many inputs are required for every algorithm? That is a basic question. At least one input is required, right? For every algorithm, we need to have at least one input. For example, during the runtime, at a runtime, if we give the values to the program, 0 or more quantities are required, 0 or more inputs are required, because you can also initialize the input. Initialize the input in the step, in any of the step. or you can initialize the input in the program itself. So externally, right, during the runtime, you need not give any input. Instead, the input can be initialized in the particular step itself or initialization step itself. That stage, anyhow, at least right one input is required for every algorithm. Without input, we cannot expect the output for the given real world problem when it is converted into the algorithm. So considering the input criteria, carefully define the number of inputs required and initialize the number of inputs or provide the inputs during the runtime of the algorithm or during the runtime of the program. So this is one important criteria, input. Second one, output. Since algorithm is the input output transformation, we have said that at least one input should be given to the algorithm. In that case, we are expecting at least one output. So with respect to output, how many quantities are produced? How many quantities? That means outputs are to be produced by the algorithm. The answer to the question is we are expecting at least one output. Similar to input, right? We need to provide at least one input that results in the expected output. So quantity wise, one output, at least one output is required. So output is the second criteria in defining algorithm. Third one, finiteness. Finiteness in the sense that every instruction or the number of instructions, in the algorithm, number of instructions in the steps. This would be a finite one, countable one. For example, if we like to add two numbers, we can input the values of variables, say A and B. Input A and B, or initialize A and B. We can find right sum is equal to A plus B. Then print sum, stop. These are the steps to be returned. That stage, how many number of instructions we can say input A and B or initialize A and B, right? Those are instructions, say two instructions. Find sum is equal to A plus B, that is one instruction. Print sum, that is another instruction. Stop, right, another instruction. So it should be a countable one. That's what we should have. The finite number of instructions should be placed in the algorithm. And the fourth one is definiteness. Definiteness in the sense that every instruction should be clearly defined. Clearly defined. There should be no ambiguity. For example, if we instruct a system to execute this instruction, perform sum is equal to a plus b, or print sum. First understand, for form sum is equal to a plus b, this is one instruction. This is one instruction. Or print sum, this is another instruction. If we ask the system to perform any of these two instructions, system will reach the ambiguous stage, either to perform sum is equal to a plus b, or to print the value of sum. So the instruction should be a clear one. So this is the ambiguous instruction, right? We have provided two instructions. Out of two instructions, we are requesting the system to perform any one instruction. The thing is how the system will choose either to perform sum is equal to a plus b or to print sum. So system will reach the confusing state. So this kind of ill-defined instructions, should be removed in the algorithm. So this can be, or these instructions can be converted to perform sum is equal to a plus b. The word right or should be removed. We can directly write the next instruction as print the value of variable sum. So sequentially it gets executed. First sum is equal to a plus b is evaluated or executed. Then the value of a variable, the sum gets printed. So that ill-defined instructions are converted to or removed, and we have checked the correct well-defined instructions are placed. Then above all, the fifth one, effectiveness. Effectiveness in the sense that each instruction must be sufficiently basic. Each instruction should be an effective one to reach the output from the input-output transformation. Suppose the algorithm consists of 50 instructions. All of the 50 instructions should have the worth, or all of the 50 instructions must be effective to achieve the required output. In case, assuming that 4 instructions, for example, these are not necessary, or these instructions are not required to achieve the correct output, we need to remove those instructions and keep only the effective instructions in the algorithm. So before going to write instructions in the algorithm as a stepwise procedure or a flow diagrammatic representation, we have seen that how an instruction should be, right, and what will be the criteria of an algorithm. So having these criteria, input is necessary to convert the input into the required output. Second, every algorithm must produce at least one quantity as the output, because algorithm is a sequence of steps that are going to be executed on the mathematical machine. The steps are going to be executed sequentially. Step 1 is executed first, then step 2. After the complete execution of step 2, control goes to execute step 3. Then sequential execution is taken place. Nth step is executed. Then n plus 1th step will get executed. So sequential execution, to have the sequential execution, finally we need to have at least one output. The third criteria is the finiteness. Total number of instructions in the algorithm should be a finite one. Then only it takes a finite computational time and a finite storage when the algorithm or the program is executed. Fourth one, definiteness. Every instruction should be clearly defined, then only the system will execute the assigned task or instructed task. Simply, the system will execute the instruction only when the instruction is well defined one. If not, the ill-defined instruction will never get executed by the system. There will be a hack. Then finally, effectiveness, to convert the input into the required output. Only the essential, necessary, effective, basic instructions are placed in the algorithm. Other than that, in case if some other instructions are available, those instructions are going to be removed from the algorithm, are removed from the steps. Hope you understand what is an algorithm, how do we represent an algorithm, and what are the criteria of an algorithm. Having these concepts, now we are going to design, write algorithms for some problems. Are you all understand? Have any queries? Up to this, have any queries?
No, sir.
Okay.
Sir,
Now, yes,
sir, can you explain again the effectiveness?
the effectiveness, very good.
Thank you, sir.
Effectiveness means, yeah, wait. Effectiveness means you need to find each instruction. For example, if you want to find the sum of two numbers, that's the thing that we are going to write next. We can input the variables, find the sum is equal to a plus b. Then we can directly print the value, print sum. After sum is equal to a plus b, for example, a and b are input variables, then print sum is enough. In between these two instructions, we need not have any other instruction. For example, if you write a product is equal to a star b, the problem is to find the sum of two numbers. Product is equal to a star b, or difference is equal to a minus b. Assuming that these are some other instructions available in the program, anyhow, finally the algorithm outputs the value of sum alone. Why do we have unnecessarily product is equal to a star b, or difference is equal to a minus b? Those are the incorrect instructions, or ill-defined instructions, unnecessary instructions, right? Not essential, not effective instructions. So those instructions are removed there so that your algorithm, right? For example, sum is equal to a plus b, then print to sum, outputs the required or expected quantity. So in between here, having difference is equal to a minus b, product is equal to a star b, unnecessary instructions, so that these instructions are removed because the target of the problem is only to find the sum. So have only sufficiently basic instructions or effective instructions. Clear?
Yes, sir. Thank you, sir.
Okay.
Sir, I have a doubt in
Now we are
effectiveness.
going to write. Yes. Tell me.
Sir, for suppose if our instructions is to find the difference and sum of two numbers, we are going to give two instructions, right?
Okay. Yeah.
So giving the two instructions in the same line and giving them different lines, will the effectiveness increase or not?
You can give the number of instructions, right, separately, or if you like to print the or execute the instructions in the same line, that will not have any significant effect, because in the same line you do like to find sum is equal to a plus b, then sequentially we need to find difference is equal to a minus b, sum is equal to a plus b, then difference is equal to a minus b. You are provided two instructions in the same step. That is not an issue. There will be no significant difference in that case. But effectiveness is concerned.
So only the number of instruction matters and not the number of lines of code.
Not the number of lines of code, only when the number of lines of code, suppose if it is n lines of code, LOC, we can say line of code, lines of code. All of these n lines of code should have the worth to compute the required output. That's what we have said. The problem is to find the sum of two numbers. Don't have unnecessary, even it may be a well-defined instructions. Simply saying, don't have unnecessary, well-defined instructions to achieve the required output. Keep only the necessary instructions. So having n lines, that is not a matter. Ensure that all of these n lines are required to achieve the expected output. That is the logic of effectiveness. If not, remove those unnecessary, well-defined instructions. Clear?
Yes, sir. Thank you, sir.
Okay. Now we are going to write algorithms to solve simple problems. Please take these the problems. First one. Design or write an algorithm to find the sum and average of two numbers, sum and average of two numbers. So keep in mind that whatever is a given problem, we are going to write the algorithm in terms of steps. Keep in mind This is the structure. Step 1, start. Step 2, we need to provide the inputs, etc. Step n, here in between, step 2 to step n minus 1. For example, we need to define the computation. Finally, for example, in step n, print the results, that we can say outputs. Then in the next step, for example, n plus 1, stop. This is one possible way, the simplest way of defining or writing algorithm. Hope you understand. Now we are going to apply this structure in writing algorithms to solve the given problem. Here, how do we start? Step 1. We can use start. Process starts here. Step 2. We need to define the inputs. Sum and average of two numbers. So here we can define the inputs. For example, in terms of variables A and B. A is one number, B holds or B assigns another number. So in step 2, provide inputs or give inputs. Give inputs A and B, or simply write input A and B, whatever it is. Then step 3, we need to find the sum. So we use one variable sum here. Like A and B are variables, we use a variable sum to find the operation A plus B. So how do we write this statement? We can write shortly sum is equal to A plus B, or we can write compute sum is equal to A plus B, semicolon, or you can simply put dot, whatever is it. That is not an issue. Compute sum is equal to A plus B dot or semicolon. Step 3, sum has been obtained. Step 4, we need to find the average also the same algorithm. So write average is equal to sum divided by 2. Because of two numbers, one is a number A, another number is B. So adding these two, we have A plus B, this is sum. We have A plus B by 2 or sum by 2, this is an average. So average is computed, compute average is equal to sum by 2. Or write in short, average is equal to sum by 2. Then step 5, stop. This is basically right enough. You need not define. End, right? Step 6 end. But here we need to check the structure. Start, okay. Inputs available. Computation available. Sum is equal to A plus B. Average is equal to sum by 2. Check, we have printed the results. In case the algorithm would like to find the computation alone, not necessarily to print. right? Just to keep sum is A plus B, average is sum by 2. Results are assigned in the variables, or result is updated in the variable sum average. But how do we define the criteria of an algorithm? One or more inputs are required. At least one quantity should be produced in case of output. So here some average is computed. We didn't print, right, at least one quantity. So here we can print the results having one instruction, print sum and average. Then step 6, stop. That's all. Step 7, end, right? Not necessarily right or return. Stop, this is enough. Or step 7, right? If you want, you can end the algorithm, right? Step 7, end. Procedure ends there. Thereafter, right, no more execution. Because you can assume, right, stop to temporarily alter the program execution. Later you may resume it, right? So conveniently, right, step 6, stop, and in the next step, right, end. Say step n plus 2. So this is the simplest level to solve the given problem, where the problem P, finding the sum and average of two numbers, that is converted into sequential steps. Step 1, step 2, step 3, step 4, step 5, step 6, step 7. These are sequential execution. These sequential steps are described using the term algorithm. In case if you like to trace this algorithm, tracing the steps, trace of this algorithm. In case if you provide, right, A is equal to 5, B is equal to 6, these are inputs. The algorithm computes the instructions or operations. Sum is equal to A plus B. So clearly sum holds the value 11 and average, this assumes sum division to 11 by 2, that is 5.5. These are the outputs, and A is equal to 5, B is equal to 6. These are the inputs. So these inputs are transformed into the required outputs with the help of these 7 steps in the algorithm. Understand? Understand this problem?
Yes, sir.
Have any queries?
Yes. Yes, sir.
Yes, sir.
No, sir.
Okay. Now let us, yeah, good. Now let us solve another problem. Take the second one. Write an algorithm to find the average of 5 numbers. How do we start? I write the steps. Step 1. Step 1, start. Problem is finding the average of 5 numbers. So we can assume the inputs A, B, C, D, E. These are the inputs. Step 1, start. Step 2, input. Input is the instruction, right? So I need not write. Please enter the inputs or provide the inputs, not necessarily return. Just write a single word. input or input the variables, input the variables A, B, C, D and E, full stop. Step 3, I am writing sum is equal to, or find sum, compute sum, right? Not necessarily, right? Simply write sum is equal to A plus B plus C plus D plus E. Step 4, what we need to find? Average. So even in this step itself, we can write average is equal to A plus B plus C plus D plus C divided by 5. But we can write the simple instructions one by one. So here we can write average is equal to sum divided by 5. Step 5. What needs to be printed? Find the average of 5 numbers. So I need not print the variable sum here. I print only the variable average. Print average. Step 6. Step 6. Stop. Step 7. Say 8. So this is the simplest algorithm which comprises say 7 steps to find the average of 5 numbers. As one of you asked, sir, is it possible for us to provide 2 instructions in a single line? Certainly, yes. For example, we can write combining these two. Directly write, for example, average is equal to A plus B plus C plus D plus E division 5. Why not? This is perfectly valid. Writing right in a single line, average is equal to. Then a print average, right? Next line. Or you can write by combining these 2 steps. Average, print average as. Find average is equal to A plus B plus C plus D plus E by 5. And print it. That is perfectly right. Because we have given the instructions, right, in terms of a simple English-like statements. So I find average is equal to A plus B plus C plus D plus E by 5 and print it. That is perfectly valid. So we can write the simpler instructions as far as possible so that anyone can easily understand what has actually been written in that procedure. So that is the purpose of writing the algorithm. Hope you understand how to solve the second problem to find the average of 5 numbers. Have any queries in this?
Sir, doubt.
Yes,
No,
tell
sir.
me.
Sir, instead of using 2 different steps like sum and average, can't we just do it in one step?
Yeah, that's what I explained. You can also write, I have written here, you have not understood, right? Average is equal to A plus B plus C
Sorry,
plus
sir,
D
I
plus C
had
by
a
5.
internet issue, so I couldn't
Okay,
see
okay,
that.
no problem. It's okay, no problem. So even right, these 2 steps can also be simplified into a single step. That is not an issue. That's possible. So another question I can ask, sir, to find the average of 5 numbers, we have written 7 steps. Is it necessary to have exactly these 7 steps? Answer to the question is not necessarily, right, to have 7 steps. Or even, right, you can extend the number of steps, or you can reduce the number of steps. But logically, you need to achieve this transformation input algorithm output. That means we need to carefully achieve this input output transformation. This is defined in terms of a function f from x tends to y, where f is the algorithm, x is the input, and y is the output, or mathematically function wise we can write f of x is equal to y. F is the algorithm. Algorithm is operating on the input x. X can be write one input or more than one inputs, assuming that x1, x2, etc. is in. We have the quantities as output, right? Say y. That may be a simple y, or it can be y1, y2, y3, etc. yn. So number of steps, right? That is not relevant one, but ensure that we have properly achieved the input output transformation. That is the thing. So hope you understand this one. Let us solve some more problems. 1, 2, the third one. Find the maximum and the minimum and the minimum of two numbers x and y. These are numbers. So given two numbers x and y, 5 and 10, we need to find which is the maximum and which is the minimum. So we need to write the algorithm. Step 1, start. Step 2, input the variables. X and y. Step 3, we can check if x is greater than y, then what to write? Maximum is x, comma, minimum is y. We can write here in else part, else the condition fails, x greater than y fails. We can write maximum is y, minimum is x. Step 4, problem is find the maximum and minimum. So I am printing both variables. Print maximum and minimum. Step 5, stop. Step 6, end. So this is the simplest algorithm to find the maximum and minimum of two numbers. For example, the inputs are x is equal to 10, y is equal to 12. Inputs are obtained in this step 2. Then checking if first number is greater than the second number. 10 is greater than 12. Condition is false. In this case, we need to print maximum is equal to y. So maximum is 12, minimum is x, maximum is y, y is 12, minimum is x, x is 10, max 12, min 10. Though these values are printed in the next step. Suppose inputs are x is equal to 15, y is equal to 10. Upon this conditional statement, if checking if x is greater than y, x 15, this is greater than y is equal to 10. Since the condition results in true, maximum is x and minimum is y. So maximum, this is x, x is equal to 15, and minimum y is equal to 10. The values are printed in the next step. Maximum is 15, minimum is 10. Then stop, end, that's all. This is a way to write an algorithm. Understand? Have any queries?
No, sir.
Sir, if both x and y are equal, what will the computer print, sir?
Yeah, good question. If both x and y are equal, suppose x is equal to 10, y is equal to 10. What happens? Since x is greater than y, 10 greater than 10 is to be tested. 10 is not greater than 10. In that case, since 10 is equal to 10, checking if 10 greater than 10 is false. So control goes to the else part. In the else part, maximum is y, minimum is x. That means when these two quantities are equal, both maximum is 10 and the minimum is 10. 10 and 10, maximum is 10. 10 and 10, minimum is 10. Since the quantities are equal. Clear?
Yes, sir.
Sir.
Have any other? Yeah, tell me if you have any other doubts. Feel free to ask. Yes. Yes, any other doubts? I'm waiting for you. Shall we continue?
Yes, sir.
Yes, sir.
Okay. A fourth problem. Hope you are taking this right in your note, right? So please take the notes. Fourth one. Given two numbers x and y. Given two numbers x and y. Find the basic arithmetic operations. Find the basic arithmetic operations on x and y and print the results. The thing is, we need to devise the algorithm, right? Write the algorithm. That means we need to write the algorithm to find the basic arithmetic operations and print the results. So what are the inputs? Inputs are x and y. We are expecting the basic arithmetic operations on x and y as x plus y, x minus y, x star y as x division y. These are the basic arithmetic operations. We can also include, right, for example, x modulus y, dividing x by y and finding the integer equivalent. So assuming these are the basic arithmetic operations, we need to write the stepwise procedure. So we understand whatever is the given problem, the stepwise procedure to write the algorithm, follow this order: step 1, step 2, etc. Step n, step n plus 1, step n plus 2, for example, starting from start, finally to reach the steps, say stop and end, and do the trace rate accordingly so that we can get the solution to the given problem. In this case, we have the two inputs x and y. Having the two inputs x and y, we can write the procedure or algorithm: step 1, start; step 2, input. I write x and y. Then step 3, we need to find the basic arithmetic operations. So I write addition, or better to write sum, is equal to x plus y. As you said, we can't write more than one instructions in the same step. Right, no problem. Sum is equal to x plus y, comma, difference is equal to x minus y. Or write in another step, step 4, difference is equal to x minus y. Step 5, sum difference, product is equal to x star y. I write here. Step 6, sum difference product, then what is this? X division y. X division y. This is the division operation. So write division is equal to x division y. Step 7, this is modulus. You will learn, right, in C language, right, how to write the modulus operation using this percentage symbol. For example, 8 modulus 5. 8 is divided by 5. 1 5 is 5. After the complete division, right, the remainder is 3. Quotient is 1. Remainder is 3. So this remainder is returned. So writing modulus is equal to x modulus y. Then I write in step 8, sum difference product division modulus are all carried out. Print the results. Print, I write sum difference product, division, modulus. Printing all the results right in a single line. That's okay. Step 9, stop. Step 9, stop. Then step 10, end. So this is the algorithm to find the basic arithmetic operations on two numbers x and y. So clearly when x and y are input, we have obtained the quantities. What are the quantities obtained? Sum is equal to x plus y, difference is x minus y, product is x into y, division is x, division y, modulus, right? So this is the operator to be used, right, in C, C++ languages. So you need not worry about modulus operation now. Later we see in operators, modulus operator, this operator returns the remainder after performing the integer division. Say 8 is the dividend, 5 is the divisor, 1 is the quotient, and the remainder is 3. 3 is returned. Then we provide x is equal to 8 and y is equal to 5. Then finally we have carried out the criteria of an algorithm, printing the results. Print all variables are mentioned here: sum, difference, product, division, modulus. Step 9 and 10 concludes the execution of the algorithm. So these are said to be well-defined instructions. All of the well-defined instructions are carefully placed in the different steps. So this is a way to write an algorithm to solve the given problem. Have any queries in this example?
Sir, I have a doubt, sir.
Yes.
Sir,
tell
in
me.
case of modulus,
Yeah.
if y is greater than
Yes.
x, what will happen?
Y is greater than x.
X.
What will happen? Yeah. 1 minute. I explain the modulus operation in the next slide. Look here, the mathematical operation x by y. Mathematically, we will be writing this is x division y. In your school days, remember that, for example, 12 by 15, this is same as 12 division 15. Here, this is a sign for division. This is also the sign for division. So understand, both 12 by 15 or 12 division 15, both are equal first mathematically. There is no doubt in that. As far as the modulus operation is concerned, in C language, modulus is equal to x. This percentage symbol y, this should be written as x, say mod y, because this mod is implemented in C languages using percentage operator. In some other things like MOD is used. So better to write x mod y or x modulus y, no problem. So keeping in mind x modulus y, you just forgot this percentage symbol. I use the generic one, x modulus y. When x is divided by y, what is the mathematical term given to this x? X is to be the numerator of the fraction. So x is to be the dividend. What is y? y is divisor. So when the dividend is divided by this divisor, after the division operation, here we will get quotient. Here we will get a remainder. Suppose Q being the quotient and let R be the remainder, X division Y, right? This is equivalent to this remainder theorem. X is equal to dividend is equal to divisor into quotient. So Y into quotient plus remainder R. This is the basic division theorem. X division Y is carried out, or X divided by Y is represented as X is equal to Y into Q plus R. Mathematically, this is a dividend. This Y is the divisor, Q is the quotient, and R is the remainder. For example, 10 division 7, 1 7 is 7, remainder is 3. So 10 is returned as 1 into 7 plus 3. Right hand side is 10. Here is 10. So what is 3? 3 is a remainder. Suppose, as you asked, please, the next slide. 17 division 25. That is this operation. 17 by 25. 17, 25. 0 times 0 into 25, 0. Remainder is 17. So this modulus operator returns a remainder. Modulus, please take this. Take this. Modulus returns the remainder after performing the integer division. X by Y. So 17 by 25 is equal to question mark. Using remainder theorem, we have studied right in 7th, 8th, 9th, 10th standards. 17 is equal to 25 into 0 plus 17. This means this is the dividend. This is the dividend. 25 is a divisor. This is the quotient, and remainder is 17. R is 17. So this is the case when the numerator is less than the denominator, or when the dividend is less than the divisor. Am I right? When the dividend is when the dividend is less than divisor, then what happens? Remainder is 17. What is 17? 17 is the dividend. Remainder is equal to dividend with quotient is 0. This is one fact you might have studied in school days, right? Please recall that. Another one, when the dividend and the divisor are same, say 25 division 25. In this case, 25 division 25. 1 into 25, 25. 0. 0 is the remainder because Using the division theorem, we can write 25 is equal to 25 into 1 plus 0. The 0 is the remainder. So please recall these facts from your school days. X mod x is equal to 0, or I write a modulus x modulus x is equal to 0 for all x. Second, x modulus y is equal to x if x is less than y. Example is 1. 17 modulus 25, that results in 17 because 17 is less than 25. So these are the facts regarding the modulus operation. Clear?
Yes, sir.
Yes, sir.
Have any queries? I like to complete one more problem, please.
No, sir.
Okay. Next problem. 4 to 1, right? We have solved 4 problems, 1, 2, 3, 4. Please take the fifth one. Next one. Let us solve right this problem in this session. Fifth problem. Given two numbers x and y. Given two numbers x and y. Write an algorithm to swap x and y. This is the problem. An important one. Solution. First, understand the problem. Two numbers are given, x and y. We need to find a swapping operation to exchange the content of variables x and y. For example, x is equal to 5, y is equal to 7. These are the inputs. We need to write a swap algorithm or an algorithm to swap the two numbers. After executing this algorithm for the inputs x is equal to 5 and y is equal to 7, what are we expecting? X should have a value 7 and y should have a value 5. This kind of swapping, this is nothing but exchanging. Hope you understand. Exchange the value of variables x and y. So the value of x is assigned to y and the value of y is assigned to the variable x. This is said to be the basic swap or exchange operation. We need not write any other variables additionally. So having these two variables x and y, right, we can write the well-defined instructions, in terms of steps so that we complete the writing of an algorithm to swap x and y. I write the algorithm here. So please take it. Step 1, start. Step 2, input the variables. That means the value of the variables x and y, right? Input the variables x and y means input the values of variables x and y. Say x is 5, y is 7. Step 3, I like to find the value of x as adding x and y. Hope you understand the meaning here. I write here inside, suppose as we discussed earlier, x is 5, y is 7. X is 5, y is 7. These are inputs. When we write x is equal to x plus y, what happens? X is equal to x plus y means the values of variables x and y are added and the updated value stored in the variable x. So shall we write 5 plus 7, 12, x is equal to x plus y, x gets updated to the addition of variables x and y. Don't have any confusion. Right hand side expression is evaluated and the result is assigned to the left hand side variable because this is an arithmetic assignment statement. Left hand side variable is equal to right hand side expression. Right hand side expression is evaluated and the result is assigned to the left hand side variable. So x becomes 12. Step 3, x is equal to x plus y. Now, x is updated to 12. Now, if I write x is equal to the current x 12 minus, or I write y is equal to how do we exchange the values? X is 5, y is 7, x is equal to x plus y means x gets updated to 12. Do you have any logic from the updated value of x?
Y.
Yeah, how do we write the next statement to bring y into x or x into y?
So x minus y.
Y is equal to
X minus y.
x minus y. Y is equal to x minus y or x is equal to x minus y. That's the correct
Y
statement.
So y is equal to x minus y.
y.
Are you sure? Y is equal to x minus y. Now what happens? Current x is 12. Current y is 7. 12 minus 7, 5. The variable y gets updated to 5. So writing y is equal to x minus y carefully because 12 is held in the variable x. 12 minus the current y. 12, understand? 12 minus the current y, 7. Current x minus current y. 12 minus 7. The result is 5. 5 is being stored into the variable y. So I write here y is equal to x minus y, so that the variable y is updated to 5. So what is the current x? Current x is 12. I am writing the current y. Current y is 12 minus 7, 5. Then what we need to obtain further, x is obtained or x is exchanged to y, we need to update the value of x. So in step 5,
So x equals x
Right?
minus y.
X is equals to x minus y.
Yeah, very good. So we write x is equal to x minus y. This means current x is 12 minus current y is 5. 12 minus 5, 7 is updated into the variable x. So writing x is equal to x minus y. In this case, what happens? Initial values of x and y. X is 5, y is equal to 7. These are updated to x is equal to 7 and y remains 5. Y is equal to 5. So the value of x is stored in a variable y and the value of y is stored in a variable x, so that the contents of variables x and y are exchanged, swapped. So required computations are over, having in these three statements: x is equal to x plus y is equal to x minus y, then x is equal to x minus y. So I write in the next step, step 6, print the variables x and y. Step 7, stop. Step 8, end. So this is the algorithm to swap the two numbers x and y. We didn't use any other variables, right? Only the variables x and y are used in these instructions. So having these three statements, ultimately the variable x is moved to the variable y and the variable y is moved to the variable x. So this is one possible solution. Can we guess other possible solution? Can we guess the other possible solution in terms of steps 3, 4 and 5? Do we have other possibilities in steps 3, 4 and 5?
Yes, sir.
Sir, can we replace addition
Yes.
with multiplication and difference with division?
Very good, that is correct, exactly. So the addition is replaced by multiplication. I write x is equal to x into y. Then the subtraction is replaced by the division operation. Then x is equal to x division y. These instructions are also give the same solution, x and y, updation of x and y. X receives y and y receives the value of x. So this is to be the basic swapping operation. So in this session, we have explored these things. First, let me summarize. Then if you have any queries, you can ask. So in this session, we have focused on what is an algorithm, how to define the term algorithm. Why do we need the term algorithm? Because to solve the real world problem, first we need to write a stepwise procedure. So the term algorithm is required. We have seen what is the well-defined instruction and the ways of representing an algorithm, pseudocode and flowchart. Pseudocode is nothing but we need to write the normal English-like statements. So we write step 1, step 2, step 3, right? Same as, right, pseudocode. Normal English-like statements, we need to provide the instructions. That is also a pseudocode. Flowchart, later we see, right? The next session we will focus on, right? How do we convert, right, the algorithm into the flowchart representation? That's simple, a diagrammatic representation. We have focused on the 5 different criteria of an algorithm: input, output, effectiveness, finiteness, definiteness. Then we have focused on the general structure of the term algorithm. How do we write the algorithm in terms of input-output transformation by using some steps. In each step, we need to define the well-defined instructions, right? Step 1, step 2, step 3, etc. Step n plus 1 something, right? Starting from start, we need to finally end with start and end instructions. We have solved the problems, basically finding the average of 2 numbers, finding the average of 5 numbers, maximum and minimum of 2 numbers, and given 2 numbers, how to find the basic arithmetic operations. Modulus operation we have explored, right? Now itself we have explored the modulus operation, then basic, right, division theorem or remainder theorem. Then you need to remember, right, these 2 facts, very important mathematically, right? These 2 facts, right, should be remembered. Later, right, we will apply these facts in solving the problems using C language. And finally, we have discussed how to swap the values of the 2 variables x and y. Have any queries in this session? If you have any doubts in this session, please feel free to ask now. Any doubts?
No doubt, sir.
No, sir.
Others, I am waiting for you few seconds. If you have any queries, please
No,
ask
sir.
me.
No, sir.
No, sir.
No, sir.
No, sir.
No, sir.
Okay, thank you very much. Please wait for a few seconds. First, let me close the recording. Thank you very much.